The oil absorption number, or OAN, is a crucial parameter in the world of rubber compounding. It essentially measures the amount of oil a specific quantity of carbon black can absorb. This absorption capacity is directly related to the surface area and structure of the carbon black particles. Imagine tiny sponges absorbing liquid. That's a simplified way to visualize OAN. OAN is expressed in milliliters of dibutyl phthaleate oil absorbed per 100 grams of carbon black. Dibutyl phthaleate, or DBP, is a commonly used oil for this test due to its consistent properties. A higher OAN indicates a greater ability of the carbon black to absorb oil, implying a larger surface area or a more complex structure. Understanding OAN is vital for rubber manufacturers as it directly influences the properties of the final rubber product. The amount of oil absorbed by carbon black affects the viscosity, reinforcement, and overall performance of the rubber compound. Measuring OAN is particularly critical when working with carbon black, a common reinforcing filler in rubber compounds. Carbon black, in its various forms, enhances the strength, durability, and other key properties of rubber products like tires. By determining the OAN, manufacturers can predict how the carbon black will interact with the rubber matrix. This prediction is crucial for controlling the viscosity of the rubber compound during mixing and processing. A higher OAN typically leads to a more viscous compound, requiring adjustments in the manufacturing process. Furthermore, OAN provides insights into the reinforcing potential of carbon black. Higher OAN values often translate to stronger reinforcement, leading to improved tensile strength, tear resistance, and abrasion resistance in the final rubber product. The OAN test, while sounding complex, follows a relatively straightforward procedure. The process begins by weighing a specific amount of carbon black, typically around 1 gram. This sample is then placed on a glass plate. Next, dibutyl phthaleate oil is added dropwise to the carbon black using a burette. The mixture is continuously mixed using a spatula. The end point of the test is reached when the carbon black oil mixture transitions from a dry powder to a semi-plastic paste, forming a ball that breaks with a slight separation. The volume of DBP oil used to reach this endpoint is recorded. This recorded volume, expressed in milliliters per 100 grams of carbon black, represents the OAN. The test requires precision and careful observation to ensure accuracy in determining the endpoint. OAN significantly influences the properties of the final rubber product. A higher OAN generally correlates with a larger surface area of the carbon black particles. This increased surface area allows for more interaction between the carbon black and the rubber molecules, leading to enhanced reinforcement. This enhanced reinforcement translates to improved tensile strength, tear resistance, and abrasion resistance in the rubber product. For instance, tires with higher OAN carbon black exhibit better wear and tear properties, increasing their lifespan. However, a higher OAN can also result in increased viscosity of the rubber compound, making it more difficult to process. Manufacturers need to carefully balance the desired reinforcement with the processability of the compound.